There we go. So, good evening again and welcome to Creative Talk. I'm so happy to see all the crowd here. Thank you so much to the organizers of PyData, because it is a great pleasure to have the event organized here at Creative Talk. My name is Hanka and I work as a data scientist here in a big data team. And you know, Creative Talk is all about innovations, and we do innovations in many different areas. And tonight I'll be talking about innovations, or as I changed the name of the talk, digital transformation in insurance and banking. So first of all, let me do a quick survey. How many of you like your bank? Who is excited about your bank, what a service is? Can you raise your hands? Okay, that's good. Quite a few people. Kind of expected that. What about your insurance company? Not so many, okay, but still someone, yes, good, thank you. Kind of expected, right? So if we talk about innovations, it is first of all important to say why we do them. And honestly, this has been a struggle to me. Since I joined Creative Talk, it was always, yeah, we're doing innovations, but come on, it's been working somehow, right? So why do they need to do innovations? And then I had a look at the way that the population is structured. Okay, boomers, they're really happy, right? They got their services. Then it's the Gen X. My parents, basically, they're also pretty happy with the services. And then it's coming. It's me as a millennial, and the next one is a Gen Z. And now I'm thinking, okay, so what kind of insurance we might be selling? Let's say it will be a life insurance. Are you selling life insurance to boomers? No, not anymore. They either have it or they don't need it anymore. So the crowd that you're actually offering these projects to is millennials and Generation Z. The market has changed because the times are changing. Heard that someplace, right? So if we just go into comparing the two generations, and you might notice that in my talk, I might not even mention the word Python, because I kind of believe that we need to talk about concepts first before we go into implementing them. Well, so why do we actually do these innovations? Generation Z or millennials, even the Generation Z, are not using Facebook. This might come across as a bit of a surprise to people who grew up with the platform, like myself, but when I heard about marketing data, they told me, well, you know, you do marketing for someone who is 22, 23, 24, you have to use Instagram because their Facebook attendance is actually dropping. It's like, why is that? Well, the sweet secret is that each generation has their own social media platform, because that's the one where you don't have your parents on it. You know, you get used to a different paradigm of working, of existence in the world. They use different devices. For example, millennials, they will be using desktops. I'm one of them. I love my computer, and I'm always pretty desperate when I have to work with a phone device, because you know, my fingers are just so big, and I wasn't really born with a thumb in the way that it fits the smartphone. Don't know how you feel about that, but it actually hurts. I mean, after some time that I use the smartphone, my thumb starts hurting. The new generation, they don't have that because they grew up the way. Usage of TV, usage of laptops, everything changes. And then, okay, marketing people would say, okay, they have least attention span of 8 seconds. It's not true. The truth is that the Gen Z and the people whom we're building the products in the next 5–10 years for, they have a very sophisticated filter because they grew up in a world where a lot of information is meshing on them. So if you're able to keep their attention, if you're able to create a product so that they really like it, they will read it. You will have their focus, but you have to think about it first. So psychology gets into game, and when I think about how the media actually work with me, then I always think, okay, this is a great example, because you might know these carousels on Facebook. What does it say? I show you half of the image. Just half of the image. Because you want to see more. I am trying to get your attention. You press the button, it shows you the full image, and then the half of the next one. And this is exactly the paradigm that many companies have been able to adopt. But many haven't. And one of them might be the insurance or the banking system. Let's go to a bit more examples. So which series did you guys grow up with? That was mine. It was airing when I was 15. I see some people nodding. Yes. So it's much more about community. It's much more about living together. And it's much less about actually being successful in life. If you go a couple of slides back, you will see that the Generation Z has exactly these targets. Millennials, yes, we are ambitious, but Gen Z might not be as ambitious. They might want to be special. Every one of them is special, right? They have been taught that. And if you think about psychology again, and now compare these services to your favorite insurance company. You hungry? At midnight, get your pizza, have it at home with your friends. Don't go into an expensive restaurant, have it delivered. You want to go someplace? Yeah, taxi drivers, a really bad reputation. Really bad reputation means that you want to replace the service. You are not providing a different service than if you go by taxi. You're providing a different feeling. Again, Spotify, perfect moment, play the perfect song. You exactly choose what you want to have. So, enough for the marketing theory. Now, how do we do these innovations? Sit in the corner. Sometimes someone comes and asks, like, can you actually do this? Or, I have an idea, how do you approach that? So, my answer always is, if you can draw it on a whiteboard, then I can explain it to the computer. And this is actually the paradigm that I think innovations live with. We really have to think about what kind of areas we want to innovate before we start smashing it into neural networks. Because everyone talks about machine learning, but no one really talks about what we use it for. I've put together a couple of different areas in which we have done innovations, and I will show you step by step how these innovations can be built up. And of course, just to say Python is running beneath most of them. We can talk about customer experience. I will go a bit deeper into this model later because I also have a case study of how to really implement one of the things that I'm presenting. But if you think about customer experience, so you crash your car, right? What do you do now? Call your insurance company, fill in a form. Oh my gosh, there is a car flying into space on a SpaceX and you're still calling your insurance company. Do you like it? No. You want to do it with your phone. So, just take pictures. There is a neural network behind that actually does the evaluation. It's got the automation of the liquidation process. It tells you which parts of the car have been damaged, and it also shows you the estimated cost. And then the company says, okay, we have some kind of an anti-fraud, and it pays the bill. Works well. So where's the real innovation? I know you're removing manual work, which means that you will have to restructure the market, but that's what innovations are about. You give people more time. Now, there is a lot of human work involved with the Crash app, just a prototype yet. You have an expert system. What it is about, customer experience. Customers want to have simple experience. You call Uber, you don't go by taxi. What about car insurance by themselves? So when you hear about insurance, people very often say, okay, I've been paying for a long time, I don't get so much back. How is it possible? Well, that's how insurance works, but still some kind of innovation is possible in this area, because you talk about people, human feelings, and feelings are important, face it. So what if you just give someone 30% back if they drive well? There's a lot of data science involved. And now if we do brainstorming, I will bring a whiteboard. You will come up with most of the ideas behind this app within 30 minutes, I promise that. You need to cut curves. Okay, the warping. It's in library. Maybe you will tweak the parameters. But what is really important is to say there is a concept of personalization that the Python and the data science that we all know has to be applied to. Yeah, that's basically what I summarized before. A lot of data floating in the app. You have to have anti-fraud checks. You have to have checks of speeding. You have to be able to evaluate the customer's behavior. Because if they behave well on the street, you give them a cashback. That's also a public service thing. So you motivate people to drive carefully. You're bringing back to the society, you don't even know it. You can measure their acceleration. How do you do that? With a phone. It's got all the sensorics you need. You cannot use gyroscope and all the stuff that is in your iPhone for measuring a distance because it's got a squared error. But you can use it for measuring other values that give you a certain idea about how the person is or is not speeding. Data science included? Yes. Do you need people to label your data? Yes, of course. But still, it's mainly about personalization, about giving a user the feeling that they are involved in their own insurance cost. Not just, okay, how many of you insured your car on the name of your parents because they've been driving for 20 years and never had an accident? Okay, don't raise your hands. I know. Yeah, but I know a lot of people who did that. Why? Because that's the only personalization that you currently have in the car insurance. Just, hey daddy, you haven't had an accident for 20 years, so can you please reduce my cost of the insurance? No, now you can do it yourself. And then a third example, which features personalization and simplicity, is the insurance mutu-mutu. It is life insurance, and again, it solves a couple of different issues that people have with life insurance. For example, premiums back if you have a healthy life. What is it? Personalization. What is it? Your own individual responsibility for how much you're paying. You get a lot of bonuses if you live healthy. Not so good for smokers though. It is simple, right? If you have a insurance, life insurance, that very often you would be like, yeah, does it really hold for this and that situation? There are a couple of exemptions, but only 8. If you have a look at other life insurances, you'll be counting much more than that. So simplicity is also very important. You have a simple website, you can apply to that. Now again, what kind of data do you need? Cell phone? Great. Google Health? Great, you have it. So make interfaces. If you do some running, if you do exercises, they also give you a watch so that you can measure it in a gym. That's the innovation behind it. So think about the user, go towards the user. If you do regular medical checkups, again, you get bonuses. No Python included in these ideas, and all of you know how to implement it if you think for 25 minutes and have a beer. Now, I know that there are a couple of technical people, I've heard. So I also wanted to give you a bit of a case study on how we implemented the Crash device, the Crash app. Crash means, well, my aim is to identify if a car is broken, how much it is broken, and if it can be repaired or not. Now, you see this image and you say, well, there is a neural network behind it, right? So, yeah, pretty much. Is it damaged? Is it no damage? Is it surface damaged? Is it just scratched? It's labeling. But okay, let's get into it. So first of all, maybe at this point I should go back to the audience. Do you guys have any questions so far? Nope. Okay, then afterwards maybe? Yep, go ahead, go ahead.
The car was crashed in the very beginning. Some kind of
You have to submit the images of the car when you conclude the insurance. So you would always have a checkup at the beginning what kind of car you're actually insuring in the insurance. So if it is crashed in the beginning, sorry, but it will be visible. Thanks for the question though. The same way Cubic, there was insurance for small devices. You could insure a couple of devices. You would first have to take pictures of the devices. The biggest trouble there, how do you take a picture of your phone, by the way? Sorry to the guys from Cubic. Any other questions? Good. So first of all, you do a labeling and classification and detection of car parts. Easy peasy. You see the lights, you see the wheels, you see the front part. How you do it? you get images. Not so difficult. Google a car, Google a crashed car, you find a lot of images online. There are also data sets that you can use for it. Or if you have a client that you're cooperating with, of course they're going to provide you with a lot of data that they have collected over the past couple of years. What is also important, knowing the pose of the car. So first of all, you train a small classifier that gives you the pose of the car. I'll get to this a bit later. But you see, there's nothing really difficult with it. So that's why I'm arguing that data science nowadays is more about the concepts and ideas than about really using the right algorithm, because all of them somehow work in the same way. You do some feature learning. How many times have you seen an image of a neural network like this? Have you ever seen a different one though? No, this is a CNN, simple CNN. So first you search for car parts of unbroken cars, and then, what is really important, manual labeling. For manual labeling, you can use services that are out there. Simply speaking, you send the pictures to India, or you find someone who will do it in your company. Depends on how you want to approach your data. Depends also on how much your data is generic, that you can use it, or if you need some kind of a very specific knowledge of the data, right? Because the more specific data you have, the more inside of the company you have to work with them. RCNN, regional convolutional neural networks, you can find them in TensorFlow, and they give you a boost, they give you a speed up, and a very high precision of the car parts, more than 95% precision of recognition of the car parts. And then the evaluation of broken and non-broken car parts. So you have to say, okay, this is a wheel and it's not broken. It's basically about how many images you're able to collect for the neural network and how much precision can be raised in your algorithm. Just to go through the model, first of all, you need to decide the viewpoint of the car, because it will be different from the back and different from the front. So this is the first classifier that you put on the way. Then you use the regional convolutional neural networks that you feed with. You don't need that many images, by the way. So if you go with 1,000, 2,000, you can already achieve good results. If you want to have more precision, of course, pair up with a company, and this company will probably provide you with more images, and then they might also have labels. If not, labels are the crucial part of the whole process, and they're most difficult to obtain. I see a hand raised.
Yeah, just I want to ask 1,000 per view or 1,000 in total?
Yeah, 1,000 per view is good. Yeah. You need to have more specific images of the broken cars. So car that is not broken is not so difficult to learn, but car that is broken, because there are different or variety of images, these images need to be more frequent in the data set if you want to be more secure with the broken parts of the images. Thanks for the question. Yeah, and like I was saying, then if you use data from an insurance company, then they would have usually around 20 images per insured event. 10 will be from the inside, 10 will be from the outside. With this network, you can also use Mechanical Turk. So that's a service that provides you with labeling if you have data that is well understandable if distributed across the world. And the final model was trained with approximately 80,000 images, 20 images per insured event, and every annotation counts for the whole insured event. So you have to do aggregation. Aggregation is easy, take the average. Is this clear? So how it works, it is able to detect broken car parts or damaged car parts, not only after an accident, but also, like you see, if they're rusty. That's pretty much all for my talk, and now I'm open to take questions. Thank you, guys.